I'll go ahead and start if you're still gone, you won't miss anything in this first part. But this is out of the C Sharp Programmer Study Guide for the MCSD. And the idea on this is it prepares you to take this exam if you want to. And talking about here, it's essential to learn the fundamentals of C Sharp programming, which we've been focusing on. And so this chapter is going to be a lot of various items that we've already looked at, and there'll be some new.
All right, I'm back.
Okay. I was just giving an overview of what this chapter is about. This is out of the C Sharp Programmer Study Guide. Talks about how to create a new project. We've already looked at that. Goes through that. But it's specifically focusing on a console application. And this is what I had to do a quick check because I realized I never checked that on the free version. I assumed that it worked on the free version. But sometimes assuming isn't good. So I created a console application real quick just to check to make sure that it works on this version. To create a console application, you do a File, New, Project. Again, you want to be in the Visual C Sharp part. It's under Windows Desktop, and you see Console App right here. Give it some kind of name, just like before, and then again, note the location because you have to zip up any project you create, and click OK. Now, the console applications, you can think of it as like a DOS application. So DOS, if I come to here and I do CMD for command prompt, then if I, do a dir, this is DOS, not graphical in any sense. So that's a console application. It uses the same programming constructs as the other one, the graphical side. And I'm going to demonstrate that in the program. I'm going to bring in two numbers, and I'll add them together. So nothing exciting. You see me do that over and over. I'm going to declare int num1, num2. Now remember, int is a number with no decimals. I'm going to do a console.writeLine, and I'll say input first number. Now the console goes out to your screen, basically. So it's your little DOS window, and the WriteLine writes something to it. In this case, it's going to write a string that says input first number. Now I'm going to do num1 is equal to. Now there's also a console read line. Like that. Now num1 is an integer. Console read line returns a string. And we saw this back when we were working with text boxes. A text box would return a string. And remember, we had to do an int. And I'll choose 32. Hopefully the case is right there. Parse.
It's a capital I.
Is it? Okay, I was wondering why it wasn't changing. That looks better. So again, this is coming in as a string. It's hitting this parse. This converts it to an integer and then assigns it to num1. Then I'll say console WriteLine. Input second number. And I'll say num2 is equal to int32.parse. Oops. Console.readLine. It is a method, so I have to put the parentheses on that, the beginning parentheses and closing parentheses in. I'm not passing anything in. Now at this point I've brought those in, so I need a variable to add them together. So sum is going to equal num1 plus num2. And then I want to write it out. So okay, console.writeLine. And as strange as it is, console writeLine is, this method is designed so you can pass anything into it. I shouldn't say that, but it's got a lot of different variations. You see here it says plus 18 overloads. So you can pass in different items to this. To say you can pass anything in the end, though, may be a little bit extreme. I never know which one to choose here. I always have to try it one time, and I didn't even notice when I ran it before I started recording which one it was. But if I did debug, start debugging, let's try this one. And Avast, no, it didn't pop up. Okay. Avast, I'm thinking my computer home. 3 and 2, that's not the one. With a console, you deliberately or you specifically want to pick start without debugging. Then if I do 3, 2, what it'll do is it'll stay on the screen so you can see your output. If you choose the other one, start with debugging, it does it. It calculates 3 plus 2. It prints it to the screen and then immediately closes this. And then press enter. Now, if I look at where this is stored at, Kali instructor source repos. Boy, that's sad. I used to know how to sort by date on this. I think that one. dir/o-d. Let's see if that's right. Order by date. Yes, I did remember. Console app 12. Okay, I do cd space console app 12. Console app 12. Debug, I think, or bin. I don't remember. Bin. Debug. Console app 12.exe. You notice it's popping up and asking us for the first number. I put 3 in here. Ask me for a second number. I'll do 4. And adds it together. So I created an application that I could sit here and run in the command prompt. A little bit more to it than that. It's not an exe where you can just copy that to a new machine. I think you have to install the Visual Studio libraries that go along with it. But that shows you can run that. What's the benefit of that? Well, if you're trying to create something that you don't want to run within Windows, they want to run in a batch file, then this is the way you can do that. We haven't really discussed batch files, so don't worry about that too much. Just remember it's not a GUI. Okay. So that's what it's referring to as a console application. It's talking about what everything is and so forth. Using statement helps to import namespace in the program. These namespaces have types we can use to develop applications. So kind of simplifies our code by bringing in other people's code that they've already written and designed. Main, C# program must contain main method. It's where execution begins. We've looked at this with a data type, and then your variable name, and then you can have it equal to a value. So nothing too exciting here. But here's the information. INT, an integer, number with no decimals. Default value is 0. This is assumption here is that if you have not assigned it a value, it's by default 0. I like to ignore that and always assign a value, and I think it requires it in a lot of cases. But that's its default value. Here's a memory size, 4 bytes, so forth. As I go through here, here's a float, and it's a number with decimals. And you can put an F on there to convert a number to a float. Down here is a double. It's a number with decimals. Difference between those is this takes up 8 bytes and this takes up 4 bytes. So if you're trying to design something to use a minimal amount of memory and you only have a minimal amount to use, then float may be your better option. So that's why they have both of them in case you're wondering. We have a character. This is a specific instance of an integer. Weird as that sounds. And it's 2 bytes. We have a byte, which is 8 bits. And we have a string, which is 2 bytes times the length of the string. So this can, the string can become kind of lengthy, depending upon what it's equal to. And we have Boolean, which is true or false, and it's 1 byte. You notice Boolean appears to be the smallest of all of them. This is why you might use Boolean as a flag instead of the other ones to save memory. Talks about some of the naming convention. You can sit there and read this. I'm not going to sit there and read the book to you. We got math operators: addition, subtraction, multiplication, division. The modulus. Modulus returns a remainder. Now I can't remember. Did we look at modulus in this class?
Not yet.
Okay. Let me show an example of that then. Looked at some of the other classes. I'm going to write a program to determine if a number is even. Now just in general, if I look at 8, if we take 8 divided by 2, that gives us 4 with remainder of 0. The 0 is our remainder. Anytime you divide by 2 and you got an even number, it'll always have a remainder of 0. Now, another way to determine something's even is you take a look at the last digit, and if it's 0, 2, 4, 6, or 8, that means it's even. But from a programming standpoint, that's quite or I shouldn't say quite difficult, but it's more difficult to implement than this code. So first thing I have to do is I have to get the number from the user. So say console write line. By the way, write stays on the current line. So it prints a string and stays on that current line. Write line goes down the next line. So I'll go ahead and use write. And I'll say input. Now, as I do this, remember how I said these have lots of variations? It says 1 of 18. It says I can write a Boolean value, true or false. Write a character value, a character buffer, decimal, double value, float, int, lon, object, and that's pretty vague, but just an object, string. So these are all the different ways that they designed this so you can use it. I'm not sure if I've ever run across something I couldn't do with the right line. Let's say input number. Okay, so now I'm going to bring in a number. So I'll do int and num1. You can even bring in a string separately. So string snum1. So you could say snum1 is equal to console.readline. Now this is beneficial to bring it into a string first if you're going to do error checking. So that's what we could put a bunch of error checking in at this point, which we'll do later on in the course. But that's a string, and now I'm going to do an int32 parse to convert it to a num1. Okay, so we brought in our number, converted it to first brought it into a string, then we converted the string to an integer. Now at this point, we want to do our if statement. So we'll check if num1, and it was %2 equals 0. So this says, go ahead and divide like normal. So we're going to take 8 divided by 2, if 8's our number, divide like normal, but what's returned is not the 4, but it's the 0, which returns a remainder. So this is then checking to see if it's equal to 0. If it is, and I'll say console.writeLine, it is even. Else, console.writeLine, it is odd. Mainly the remainder comes in mathematical programs, is where you see that a lot. Okay, so I think it was start without debugging, so let's choose this one. I expect it's probably up here too. If you do this drop down, I'm lying to you. Okay, well, I'll just do debug, start without debugging. Put my example in of 8, comes up, it's even. That doesn't mean it actually works. So let me just start without debugging, and I'll put 7 in. And it's odd. But that is the modulus operator. Now we got a relational operator. This compares two values and gives us a Boolean, either returns true or false. Then we've looked at these, greater than, less than. If you want to do the equals, you have to do 2 equals. Not equals is exclamation equals. Greater than equal to, less than equal to. And again, classes all merged together. So I'm not sure if I showed this in the C programming class or I showed it in this one. Did I show the and or?
I think you made a comment about it after someone asked a question, but I don't think you actually showed us it.
Okay. Well, let me show an example of this. I'm going to come over here. I'm going to write a program. Program to check if the age input is between 1 and 100. Maybe my program is going to come up and ask them what their age is. and I want to check to see if they put in a valid age. So I'm going to bring in age. And I'll go ahead and do this separate just so you see sage. Then I'll do console.writeLine. Keep doing want to do write line. Write is actually a little bit better if you want to stay on the same line. Input age. And sage, or string age, is equal to console.readLine. And then I want to convert that to age. Okay. Now to show how to do the and, I'm going to say if age is greater than or equal to 1, 2 ampersands is the and. Age is less than or equal to 100. Then I'm going to do a console.writeLine. And I'll say age is valid. Else, console.writeLine. Age is invalid. So this is going to check if age is greater than or equal to 1. It also check the age is less than or equal to 10. Now, let's say I put in 50. It checks this. Age is greater than or equal to 1, which is true. 50 is greater than or equal to 1, so that's going to return true. Now over here, it'll put 50 in here, and it'll say, okay, is 50 less than or equal to 100? And it is. So I return true. The two ands here, ampersands. If this is true and this is true, then that's when it'll do this this condition here. They'll do this line. Otherwise, they'll do this down here. So for the and, both of them have to be true. If I run that, I'll put in 50. It says age is valid. Now if I run this and I put in like -3, it comes back and tells me age is invalid. Now that's how you can use the and. The or is another useful one. This is checking if valid using the and concept. I'm going to instead approach it from the opposite direction, checking if invalid using the or concept. So I'm going to look for invalid data using this. So I'll say if age is less than 1, the two pipe symbols is the or, age is greater than 100. I'll say console.writeLine, age is invalid, else console.writeLine, age is valid. How this will work, well, actually first let me run and make sure it works. My code doesn't always work the first time. If I put an invalid, a -1 in, both of them come up and tell me invalid. I expect that. If I run this, I put 50 in. Both come back and tell me valid. When it gets down here to the or, this is checking if this is true. If I put -1 in here, and I ask, is -1 less than 1? It is, and so I return true. If I put -1 in here, -1 is greater than 100, that's false. So this is like true or false. How the OR works, if either one of these is correct, is true, then it'll do this line of code right here. The AND both have to be true. The OR, just one of them has to be true. Now, if both of them are true, fantastic. That's fine too. But with the OR, just at least one of them has to be true. Now, the NOT operator is where you check in the reverse, and that's kind of useful in programming. They have you take, if you go into Wichita State and you go in for their computer science, they have you take a discrete math class. And it talks about Boolean logic and has some really interesting topics in it, actually. Reversing something. Let's say if, let me see, the time is greater than, if the time is greater than 3 and it is sunny. That's not going to work because I haven't put any conditions on any of that or so forth. We're just talking about Boolean logic. Now, to reverse this to the opposite, let's say I put this in here. My program is working opposite of what it should be. Where it should be running this bit of code, it's running the else. So I want to flip them around. Coming up with the opposite of this, I don't think I could come up with. It's been too long. Time is greater than 3. I think the opposite would be less than or equal to 3. And I think you change the AND to an OR. And I would change this to it is not sunny. But I don't know. I'd have to go back and pull up my discrete math book and refresh my memory on all that. Instead of doing that, what you can do is you put an exclamation in front of that. The exclamation reverses it to the opposite meaning. Sometimes in programming over the years, I could not figure out, it was working opposite of what it should be. And it wasn't as easy as just flipping it around, like going from less than 3 to greater than or equal to 3. And it would have took a lot of mental effort to figure out how to actually reverse it. They've added this in here, so you can just do the exclamation, and that reverses it for you. Some might argue that's bad programming practice, but typically a company wouldn't want you to sit there and spend an hour trying to redo it. When you got an exclamation that you can put in there in 2 seconds and fixes it. Okay. Well, that's what those Boolean logical operators are there. We got expressions. We looked at that where you assign it a value. Typecasting. We got implicit conversion and we got explicit conversion. Implicit is what we've been doing for the most part, where you just assign it a value. This is where we implicitly say it's an integer. Now, if I wanted to convert that, I'm going to type something dirty if I don't watch it. Let's see, F underscore age, D underscore age. Okay. S underscore age. Okay, so I bring in the age, I convert it to an integer. And I assign f age is equal to age. I assign d age is equal to age. Now, if I print those out, unless I'm mistaken, they're going to look okay. Let's see, f underscore age, and I think I can do a comma here. Maybe not. It's been a while since I used console write line. Doesn't look like it. I typically program the Windows applications. Again, unless I'm mistaken, this will work. Well, it won't because I didn't choose the right one. But let me choose debug and start without debugging. And if I put 10 in here, it gives me 10 and 10. Works just fine. I went from an integer and I assigned it to a float and a double. Instead of that, let me come here and I'm going to change this to double.parse. And I'm going to assign that to d underscore age. So I'll say d underscore age there, and I'll say d underscore age here. There we go. So I'm reading in my my age. I'm assigning it to s underscore age, which is a string, and then I'm using a double.parse to convert that string to a double. Then I'm assigning a double to a float, and I'm assigning a double to an integer. Well, let me run it. Do debug, start without debugging. Nope. And it says cannot implicitly convert type double to float. An explicit conversion exists. Are you missing a cast? So it gives us a indicator there. Now we could do our conversion here. Like I think if you did float.parse, I think it would work. Let's see if that's a lie. Float. Parse. Cannot implicitly convert from double to string. Well, it'd work if I put an S in there. Nobody actually ever does that. When you want to convert, like a between the numbers, you don't actually do those parses. Here, I would put float inside a parentheses in front of it. And change that back to double. Now what this does is it will change that double to a float. And I don't usually change these right here. How do I do this? Let's see. int 32. Let's try that. Now let's run it. Let's run it again. $11.5 and 11. Our first one here converts it to a double, which can have decimals. That's just fine. When I, or right here, when I convert this one to an integer, you see it loses integer and doesn't even round it. Doesn't go up to 12. It just truncated it, so dropped off the 0.5. But that is the explicit conversion they're talking about here. They give you the example here. You just put parentheses around like that. I'm really surprised that int parse didn't work. They give the example where you're doing a string, but I guess it isn't overloaded to handle everything. Little typo there. That should be each primitive type has a parse method. Helps convert string data into the associated primitive type. I think it's primitive type. Now this one I've never used, so I thought this was real interesting. I don't consider this good programming practice. Var means you can put any data into it, so you're not telling the type. Like you do var age equals 22, var name is equal to this, so forth. The idea of good programming is use strongly typed language, which C# can be, and though var seems to negate that. If you use strongly typed, you have to declare it as a double, as a float, as an int, 32, as a string, whatever. You never just willy-nilly throw it in something. And it says always initialize the var variable with a value, otherwise compiler will generate error. Problem with this is that you assume that it's going to be a number, and they throw a string in there. So you can have a lot of programming issues with that. Now, can you get around that? Yeah, you probably can, but why throw all that error checking in when your data types will handle it from the programming standpoint? For example, let's try it since I've never used var because I don't like it. Var num1, num2. Yeah, I got the right. Oh, I have to do them separate. And then I want a double divide. And divide is equal to num1 divided by num2. And then I'm going to print it out. Zero. And we have this problem normally anyway. But this did 33 divided by 44, and it did integer division over here. Well, like I said, we'd have that problem anyway if we did int here. If I didn't do this, it should still give us 0. It does. But the benefit here is, from a programming standpoint, I'm thinking, okay, integer divided by an integer, and I'm thinking I need to handle that. When I put a var there, you're not thinking, oh, is that an integer? Is it a double? Is it a float? It's whatever we assign the value equal to. So anyway, I don't like var. Now, array is when you can bring in like an array of numbers, where you want to add numbers together. We looked at this with list boxes. You do your data type like int, double, or whatever, and then a beginning bracket, closing bracket, and then your name of your array. So that's how you declare it. Here's an example. String, and then beginning bracket, closing bracket, friends. So you declare an array of strings. Now, I'm not going to write it out, but remember, this is where you can have this equal to values like that. You could have 1, excuse me, 2, and so on. So that's what an array is. It's a list. It's a list of items. Now, to initialize it, this is where you have to do your new. So names equals new. And over here, I know it seems redundant, but we had to tell our type again. And the size. So I'm going to say string 10. You remember what our first number is we can use?
0.
0, exactly. What's our last number?
9.
Yeah, so it goes from 0 up to 1 less than your length. So that hasn't changed. You're doing that in console mode here. It's the same principle. Now here, you can still do your for loop, and they haven't really covered that in the book yet, but you can still do your for int, x equals 0, continue while x is less than or equal to 9, x plus plus, console.writeLine, and I can print out the values. So you don't have to actually have a number in there. You can have a variable. In this case, a counter-controlled one. Let's see what this gives us. I don't know what it gives us, to be honest. Something. Earlier in the book, it talked about maybe the default value for a string. And assuming it's honoring that, and I'm not saying it is, because I haven't played with it enough. If I'm gonna use it, then I always initialize it. See, this implies for a string, your default value is null. Just because it didn't print anything on the screen doesn't mean it's not null or it's not an empty string. So there's really no guide on that. Okay, so looked at an example there. You can assign it equal to values. I don't think this is very beneficial. When you're gonna bring in an array into your program, usually you're gonna get it from the user. They'll input it in, or you'll get it from a file on the computer, or you'll get it from a database file. So usually you don't actually hard code values. Could I hard code states?
Probably.
Yeah, that would work, right? Until they do what? Add a new state?
Yeah.
You might say, how often does that happen? Well, one of the politicians now is talking about adding the D.C., Washington, D.C. as a state. Because they felt it was unfair that all those people really didn't have a representative. So, in that case, if you put states as hard-coded values with these quotes, these braces around them, then you'd have to change every program that you did that in. So it's usually better to put it into a table, even if it's something that you don't think will ever change. Sure enough, it will. If you put it in a table, all you have to do is add one entry into that table. So you do an SQL command to insert it, and then it works in every program that uses that. Let's see. This is talking about a combination you can use. Multi-dimensional arrays are kind of a challenge. Here's a syntax. We got your type, and then bracket, and then empty, then comma, and then empty string, and then bracket. This is where, if I had a OINT, I'll put a comma here, A, B, there we go. And A I'm going to declare as integer, and 1 1. Now I'm going to try again. 2 2. And B is 2 2. Unless you've had college algebra, you may never have seen this before. Paintbrush. Where's paintbrush? I already got it highlighted. This is called an array. Like if I had 1 7 2 3. That's a multidimensional array. In mathematics, it's called a matrix. If I'm adding those two together, what I'm going to do is add together the corresponding entries. What I mean by that is I'll add the first row, first column here with the first row, first column here. So I'll have 1 plus 2. I'll add to 7 plus 5. Down here I got 2 plus 1. And down here I got 3 plus 6. And then that'd give me my answer. If I was trying to program that, this would be it's an array, but it's a multi-dimensional array. It has 2 rows, 2 columns. This has 2 rows, 2 columns. So over here, again, that's what the 2, 2 represents, 2 rows and 2 columns. Now I could say, and remember it starts at 0, so it's real weird. The 0th row, 0th column is going to equal to number 1. The 0th row and the first column, and I know that's strange as can be. Three. This over here, you have to consider this row 0. You have to consider this row 1. You have to consider this column 0 and column 1. So the 0, 0 is equal to 1. The 0, 1 is equal to 7, which is that one. 1, 0 is equal to 2. And then 1, 1 is equal to 3. Does that make sense?
Yeah, kind of. I don't normally use those in my everyday life, so
No, most people don't. Then if I had B,
what job would you have to use those in your everyday life?
I think if you worked for Unity, you would have to do that.
Okay.
You notice what I said there? I didn't say if you were programming games. I said if you're working for Unity. If you're writing that Unity software, you've heard of the movie The Matrix?
Yes.
Why it's called that, and the theory behind games is they keep track of your position in the game with a 4x4 matrix. So any place you move in the game, matrix calculations are done. Kind of like adding two matrices like this, except for it's more multiplication. There's like a scale, rotation, and translate. I think you have to do it in that order in the mathematics behind it. But anytime you see a 3D character move on the screen, it's doing a matrix multiplication for you. Used to be, in early days of 3D game development, you had to do that yourself. You had to do that multiplication. Now you've seen in the classes that it does it for us. We don't even know it's a matrix. But that's why they call that movie The Matrix, is because they're living in a virtual world. You know, they're in their bathtubs as batteries for the robots. And if you understand programming, you realize how stupid it is. Because if you're keeping track of somebody's location with a 4x4 matrix, if an agent sees that person at that new location, all they have to do is change one number in the programming, and their character would automatically appear at that new location. Instead, they take over the body of some character that's nearby, and no, that's not the way programming works. But anyway, that's why I say if you work for Unity, you're probably doing the behind the scenes, such that when you do a transform, the dot position, it's doing all that for you. Okay, now we could add those together if we wanted to. Adding them together, just showing you one. Console write line A00 plus B00. There's better ways of, where you can create a new matrix called C that brings all this in, but we're not going to do that. So this should add 1 plus 2 and gives us 3. And then C gives us 3. If somebody's going to major in, want to get a bachelor's, going on to Wichita State, you'll deal with multidimensional arrays. They have one interesting, and I've had students tell me about it. I've never programmed it myself. I keep thinking someday I will, but I don't. Not sure if I'm actually smart enough. Do some really heavy thinking on it. Hopefully you're not red-green colorblind. What they have you do, go away, Cortana, okay. What they have you do is they have you multiply two big numbers together that exceed the limits of the variable. An integer, I don't think, would be able to handle this. Well, what they do is they put one of these into an array. They put another one into an array. And I think it might be multidimensional. I don't know. But then they multiply these in a program and come up with the results. The idea is you're showing how to create a system utility that can multiply two numbers that are real huge that would exceed the limits of your variable. I say challenging project. I'll never do it. But that's a couple of places where you use multidimensional arrays. Talking about using loops to access the values of a 2D array. That's where you would go through from row 0 to rows less than numbers of the length. Column from 0 to 1 type of deal, and then multiply them together, or add them, or whatever. Notice this get length int32 returns the total number of elements in a specific dimension of an array. I thought there was another way. I'm probably remembering wrong. A dot length. No. There. Let's see what that gives us. 4. Oh, total number of elements is what that returns. This, oh, okay, I see. The get length, the difference between this is this just returns the number of elements on that row. So this returns the number of elements on row 0. This returns a number of elements on row or column 1. I may not have that right. I haven't played with get length before. You can play that and see. Now, jagged array in C#, it's an array of an array, which means it's kind of an array whose elements are also an array. And you see here, instead of using the comma, they have a set of brackets and then another set of brackets. That the two sets of brackets next to each other tells you it's a jagged array. And if we go down to the little code snippet, grab a drink here. You notice for each entry, I'm declaring a type, which means your first entry, the jagged 0, could be an integer. Second one could be a double. The next one could be a string. The next one could be a character. So if you're mixing in a bunch of different data types, that's where jagged array comes in handy. Now their example doesn't really demonstrate it here because all they show is they're all integers, but it doesn't have to be. Then you initialize it with the 0, 0 or 0, 1 and so forth. Does that make sense on a jagged array, what it's used for?
Yeah.
Okay. Again, in real life, what you use is databases. You don't necessarily use a jagged array like that. Jagged array has a benefit is if you need something right away, it's right within your program. One example of this I can think of that maybe you wouldn't use databases on is if you want to bring in the state tax rate. So you have your state and it has a tax rate. And you want to have it handy. You don't want to keep hitting the database every time you need it. Maybe you're going to run a program through that has 5 million records. And if you hit the database looking it up each time, that'd be 5 million lookups. And again, you don't want to do that. You want to keep it efficient. So you load it into a jagged array, and then you can access it quicker. Uses less resources. Now, that's assuming it's running at night or running at a time when they are not changing it. If you've loaded your program in the morning, and they're going to use it all day long, so you load it in, and this is not a batch where they're doing like 5 million records, but they're doing a record at a time. You load it into your application. They're sitting there, they're updating orders all day long. At 10 o'clock in the morning, somebody goes and changes the tax rate for Kansas. Your program has the old tax rate because it loaded in first thing in the morning. You have to really analyze your situation, what makes sense. If you got 5 million records, you're going to be going through and processing, load it one time. If you're going to be taking an order anytime somebody calls you all during the day, well, that's not that. You get 4 orders an hour, say 15 minutes to process each one. That's 4 times 8. That's 32 lookups. It's not a huge deal. Talks about how to print those. That's not exciting. We talked about the if statement, so we've seen example after example of that. I don't think we looked at a switch in here, though. Oh, there's our even number. If else, we looked at that. If else if, looked at that. Here's another example of that. The if else if. Here's an if statement. It's checking to see if this is true. If it's true, it prints this console write line and comes down to the end and kicks out down here. If this is not true, right here, then it comes down and checks this condition. If that's true, then it does this line of code and comes down here and kicks out. Otherwise, it does this line of code, and if that's true, it does this line of code and comes down here. If none of the above is true, no matter what, it'll sit here and do this one. So that's a flow of an if-else if. Now here's a switch statement. You see it says expression here. I think it's got a little bit more power than what they're exactly leading on here. But it's talking about how you determine if it's an even number or odd number. Let's just say if I only have that one example. Yeah, I'll just go over it. I don't like switch statements. I don't use them. I like if else. There's only one time I had to use a switch statement, and hopefully I haven't already mentioned that in this class. But I was writing a program for the production floor, and their barcodes. We're going to create these barcodes and put them on PCB boards, work orders, and so forth. And they wanted each one barcode to start with a certain character. It had to start with like .wo for work order, .sq for sequence, .po for purchase order. And they explained the reason why. They said if we don't do that, we'll have a lot of garbage data. We said, what do you mean? They said they'll go up to the little station and they'll start scanning their pop bottles, and that barcode then will be put in as a work order. So by putting a little character on the front, then they can handle that. So that's how we did the check here. Is we had a bunch of switch case statements where we went through and checked all the different possibilities. There's quite a few, and it worked out pretty well then. What this does, you can think of it as a fancy if-else statement. It does this right here, I%2. Remember, that's the modulus. So that takes 3 divided by 2, which is 1 with a remainder of 1. And the modulus returns a remainder. So this returns 1. It comes down here and says, okay, is that equal to 0? Right here. Or is that equal to 1? And since it's equal to 1, what that line of code will do is it'll run this. Now, if you're wondering, well, what in the world's that percent there, or the percent, the curly braces, 0, closing curly braces. What that does, that takes the value of I and plugs it in where that's at. So that'll return 1 is an odd number, or 1, I. What is I? Yeah, 1. 1 is an odd number. Now, powerful programming languages allow you to put strings there. Now, I don't know if this will do that. Let's see. Grade equals A. That helps if I actually declare it correctly. Okay, and then we're going to use our switch grade. And then I'm going to have my case A. And I'll say console dot write line. You got an A. Now notice here, let me do a break. Notice here we had a little red squiggly under here. We hadn't done our break. Each case has to have a break. I think the last one may, if it's the default, it'll take that. Right line. You got a B. Break. And what do we have at the end? Oh, it didn't say. And obviously I'm not going to remember syntax. Otherwise, maybe there isn't a default in
Why is it grayscaled?
I don't know. Probably because I can't do an else. Sure enough, it's maybe it doesn't have a default one. But anyway, it's a fancy if else statement. Have a case. default. Yeah. Like I say, I don't use these, so I have no expertise in them at all. So you got an A. The really good ones will allow you to put a full string here. So now if I run that, boy, my eyes are bad. Start that debugging. There we go. Where does this come in at? Well, if you're reading in like a barcode, this is where you could check to see if it's .wo. That tells you it's a work order. Or .s, what was sequence? SQ, and so on. This is the one time I ever used a switch case in 13 years of programming. Is because we had so many of these. It would have been about 20 if-else statements. And I didn't want to put 20 if-else statements. It was just too sloppy, even though it would have worked just fine. So I put this in here just so it looked clean. Does that make sense of where you use that at?
Yeah.
Yeah.
Okay. Now, this is pretty powerful, what it just allowed me to do. In C, the C programming class, we covered this last class, I think. And it doesn't allow you to put a string in like that. Only thing you can put in is like an integer or a character, a char. So those are only two items you can put in there. So not much flexibility on that. Decision operators, I don't like those. This is like taking an if-else statement and putting it into one line. What do I mean by that? Comes down here. This you can visualize an if statement right here. If this is true, then we do this. Else we do this. And when I mean we do this or this, we return that result return that to the variable called result. So if you like that, you can use it. It's just as easy to me to write out if this, then result is equal to even, else result is equal to odd. But it does have that capability. Let's talk about we don't want to store a null variable value in a variable. We can achieve this by using a null coalescing operator. It returns a left-hand variable operand if it's not null. Otherwise, it returns a default value stored in a right-hand variable. So it's kind of a where's name? Oh, here it is. So name is equal to null right here, right? Down here, it comes down, and we got this setup right here. Now, username is equal to name unless it's null, and if it's null, then it's equal to the right-hand side here, which is a string called user. So that's not bad. Kind of simplifies your code quite a bit. You don't have to check to see if the value is null. If it's null, you go to name, and then otherwise you said, or no, it's equal to user. Otherwise, you set equal to name. So kind of simplifies the coding. And I'm out of time. So we didn't get to the loops. But well, we'll go into this more on, let's see, what's day? Wednesday. We'll go into this more on Wednesday. And then I'll give you an assignment out of the book here. So we'll go ahead and stop recording there.
All right.
All right.